In this question, we want to determine the equations of the tangents to the quadratic given that pass through the point 3, -1. That doesn't mean 3, -1 is on the curve. And in fact, to sort of fast forward to the answer, what actually is happening is we have a parabola, y equals -2x squared plus 4x plus 3. We have a point 3, -1, which is not on the curve. But there's a point here and another point here, right about there and right about there, where the tangent line to the curve at that point ultimately crosses through 3, -1. Maybe this diagram makes the question make a little bit more sense. What we're looking for are the equations of these two lines. In order to find the equations of those two lines, we have to first figure out these points. So that's what we're going to do. The first thing we do is to take the derivative of the curve. The derivative of the curve, -2x squared plus 4x plus 3, is y prime equals -4x plus 4. We're then going to let xy be a point on the curve with a tangent line that passes through 3, -1. Well, if xy is a point on a tangent line and 3, -1 is a point on a tangent line, then using some pretty basic grade 9 concepts, we can see that m is going to equal delta y, y minus -1, or in other words y plus 1, over delta x, x minus 3. Well, since the y value is equal to -2x squared plus 4x plus 3, because xy is a point on the curve, so y is equal to -2x squared plus 4x plus 3, and then this plus 1 is here, and we have a denominator of x minus 3. So our expression for the slope using grade 9 concepts is -2x squared plus 4x plus 4 over x minus 3. Using grade 12 concepts, in other words taking the derivative, which we've already done, we see that the derivative at any point is -4x plus 4. Well, setting this derivative equal to this slope means -2x squared plus 4x plus 4 over x minus 3 equals -4x plus 4. At this point, we can multiply both sides by x minus 3, and we get a long quadratic equation which simplifies to 2x squared minus 12x plus 16 equals 0. Since it's a quadratic, we're going to set one side to 0, which we've done, factor, and we get x equals 4 or x equals 2. Well, at x equals 4, the y value on the curve is -13. At x equals 2, the y value on the curve is 3. So that means that one of our points with a tangent that ultimately goes through the point 3, -1 is 4, -13. And the equation of that line that goes through 3, -1 and 4, -13 is y equals -12x plus 35. Another point on the curve with a tangent line that goes through 3, -1 is 2, 3. Well, if a tangent line goes through 3, -1 and 2, 3, the equation of that, using some grade 9 concepts, is y equals -4x plus 11. So going back to our original diagram that we showed a while ago, we see that what we really have is the point 2, 3 right here, which has a tangent line that ultimately goes through 3, -1, and 4, -13 way down here, which has a tangent line that ultimately goes through 3, -1 the other way.